Hey guys, today it's Tuesday, March 24th of 2020, and I want to go over the do now question for you, which is a question on proportions with percents. So on page 1 that looks like mine, this is what it says. It says Guadalupe has a ring collection. She keeps 18 rings in a box, which is 6% of the ring collection. What is the total number of rings in Guadalupe's ring collection? You must use a proportion to solve. So the first thing that you have to do is you have to identify the part, the whole, and the percent. And in the question, the part is 18 because it's saying she keeps 18. So I'm going to put 18. The whole, which is asking for the total number, another word for whole is total, I don't know. But the percent is 6%. So now that I have the part, the whole, and the percent, I'm going to take my part to whole equal percent over 100, which is here in green where my hand is, and I'm going to substitute the numbers. So now, in place of part, I'm going to substitute 18 part numerator. The whole denominator, I'm going to call it a question mark. The percent is 6 over 100. Now I'm simply going to cross multiply, use the butterfly method, like so, to figure out what the value of x or question mark has to be. So now if I multiply 100 times 18, I'm going to circle the 2 zeros because that's the math trick. I'm going to multiply my whole numbers. 18 times 1 is 18. Add my 2 zeros. Now I get 1,800. Now I take that 1,800 and I'm going to divide it by 6 to figure out what that number has to be. So if I divide 6 into 1,800, this goes 0, this goes 3 times, this is 18. I get a 0, bring down my 0. 6 doesn't go into 0, put a 0. 0 times 6, 0, bring down the 0. So the answer would be you need to have 300 rings in her collection. Now, we're going to flip over now to page 2 now. So if we flip over this page to page 2, there's a question with unit rate. So I'm going to model how you're going to do that problem, and then we're going to keep going on. So I'm going to put a line over here. We're going to do page number 2. We're going to do problem number 2. The question reads, I'm going to read it to you. It says, Miss Canella rode 200 miles in 5 weeks, riding the same distance each week, and Mr. Rez rode 210 miles in 7 weeks, the same distance. Determine or find the unit rate for both Miss Canella and Mr. R, and which statement is true. So we're just going to continue over here. So I'm going to have my T-chart. One side I'm going to have Miss Canella, and the other side I'm going to have Mr. Rez. Now, when we find the unit rate, we are going to divide. We are going to divide the miles by the weeks to figure out how many miles I ride per week and how many miles Mr. R rides per week. So let's look at myself. We know that we're comparing miles over weeks for me. So I'm going to write miles over weeks. It says I ride 200 miles, so 200 matches the numerator in 5 weeks. So when I do divide 200 by 5, I'm going to get 40 miles per 1 week. That is my unit rate of 40 miles per week. Now let's look at Mr. Rez. Mr. Rez goes 210 miles, so I'm going to put miles. I'm going to write 210 over, how many weeks is that? That's 7 weeks, so weeks over 7. When I divide, it's 30 miles per 1 week. So now I know that Miss Canella rode more, right? We need to figure out how many more did she ride. In order to figure out how many more she ride, we have to now subtract Miss Canella, which is 40, this unit rate, and Mr. R, which is 30. So I'm going to subtract 40 from 30, and I'm going to get 10 more miles per week, and that is the unit rate for myself, that it's 10 more miles per week is what I rode than Mr. Rez. Therefore, I know that I can circle choice A. So this 10 represents choice A. That Miss Canella rode 10 more miles than Mr. Rez. Now, let's go on now to page 4. Okay, because page 3 had some notes. Page 4, I'm going to do it at the bottom of the page. This question on page 4 looks like this. Problem 3 reads this. It says, a sandwich shop sells sandwiches for $9.90 each, including tax. The shop received a total of $198 for the sale of the sandwiches one afternoon. Which equation can be used to determine the number of sandwiches X sold by the sandwich shop that afternoon? So here's what I got. Now we're going to be on page 4. We're at number 3 now, okay? Look at the red here. So we know that we have $9.90 each. Each means I multiply. I'm going to multiply the variable, which is X, to figure out how many sandwiches I can buy if, which is equal, my total amount is $198. Okay, so this equation is going to be answer choice C is the equation for part 1. So C is for part 1. Now, I need to, in part 2, use the equation to figure out how many sandwiches you can buy with $198. So now, for part 2, I'm going to use the rule method. I need to figure out what X is going to be, so I'm going to divide by $9.90 on both sides, because what I do to one side, I do to the other, to figure out how many sandwiches I can buy. So, I'm going to go here. So now you can't see me. So we have $9.90 divided by $198.00. Now, I cannot divide decimals on the outside, which is my divisor. So I have to take that decimal and I have to make it a whole number by moving it until I get a number greater than 1. So watch the red point, 1, 2. So now it's 990. If I move 2 here, I move 2 here. I bring up my decimal point. Now I can do the long division. 990 does not go into 1. I'm going to put a 0. Does not go into 9. Does not go into 198. Put a 0. But I know that 990 times some number is equal to 1,980. So I'm going to try 990 times 2. This is 0, 8, and I get 1,980. So I'm going to put up a 2, and I'm going to subtract 1,980. This gives me 0, 0, 0. Bring down the 0. This goes 0 times. So I know that I can buy 20 sandwiches, which is costing $198. So that would be the conclusion to that question, which is, this is part 2. 20 sandwiches cost me $198 because $9.90 times 20 is $198. Now, let's go on and look at problem number 5. So I'm going to move this chart paper up now. I'm going to move it up a little bit, and I'm going to do number 5 above here for you. I'm going to try to do as many as I can for you, and then, you know, if we have scheduled time to meet, you're going to reach out then. Okay, so I'm going to put this paper all the way up here so that we can finish going over the questions. All right, so we're going to look at now on we're on page 5 now. All right, so let me write it for you. It says, so we're on page 5, number 4. So I'm going to make a line. We're going to go page 5, problem number 4. Okay? So let me just see what's underneath here. I'm going to take that down. Okay. So page 5, number 4. So here we go. Samira sells 20 tickets for a school fundraiser. The total price of 20 tickets is $400. Write and solve an equation to find the price of each ticket. So we know that she has 20 tickets. We need to figure out what variable we're going to use for tickets. So I'm going to say, let, quote, T represent the cost per each or every ticket. I identified my variable. So I'm going to use the variable T. Now you can use any variable you want. You can use A, B, C, all the way up to the alphabet. I just chose T because it makes sense when we talk about tickets. Okay, now I'm going to multiply the 20 times the T to equal $400. So now I'm going to multiply 20 T is equal to $400. And this is my equation. So I wrote the equation. Now I got to solve the equation to figure out what number T equals to figure out how much each ticket is that Samira is selling at the school fundraiser. So now I'm going to do my wall method. I want to figure out what the value or what number T is. So I'm going to divide by 20 because the inverse of multiplication is division. I'm going to divide 20 on both sides. 20 divided by 20 is 1 or just T is equal to, cross off a 0. I got 40 divided by 2. I now get $20 per ticket. And 20 times 20 is 400. Therefore, that is the correct answer. So it's $20 per ticket. So where my finger is, you're going to write on this line here, $20 is the answer with that work shown. Let's go on now to page 6 now, which is another equation problem. It looks like this. I'm going to do it right underneath where we were just at. Okay, this one is on page 6, problem number 5. It says, it is recommended that one fire extinguisher be available for 18,000 square feet in a building. Write and solve an equation to determine X, the number of fire extinguishers needed for a building that has 36,000 square feet. Okay, so now this is page 6 now. Page 6, problem number 5. Okay, so we're going to look at the red part now. It tells me that one fire extinguisher is 18,000 square feet. Use X times X to equal a total of 36,000 square feet. Now, this is the equation. I'm multiplying because I want to know if this is 1 square feet, how many fire extinguishers do I need to get a total of 36,000 square feet? So now I'm going to solve the equation by using the wall method. So I'm going to make my vertical line and my horizontal line. I want to get X alone, so this means multiplication. The inverse is division. I'm going to divide by 18,000 on both sides because I want to get X by itself. I'm going to divide by 18,000 here. I'm going to cross off my zeros and line them up. And 36 divided by 18 would be 2 fire extinguishers, would be actually the answer because 18,000 times 2 is 36,000. And that is the answer to page 6, problem number 5. Okay. We're going to actually go over page 7 now. That looks like this. It's actually a PEMDAS question, okay? So I'm going to do that one on another chart paper. I'm going to move the chart paper. I'm going to take this one down from my wall, and I'm going to move this one over for you. So just give me a moment to take this chart paper that's over here for you guys and put it on the other side of my patio door for you. Okay, here we go. Here's what we got. All right. So we got this. We got. Oops. Okay. I think we're ready. We're rocking and rolling now. Okay. So let's look at this question that is. Okay. I'm going to use different colors now. So this one is on page. Where did it go? Here it is. Page 7. Okay, that's the problem we're going to do. Page 7 now. So let's write that down. We got page 7, number 6. So we have page 7, number 6. Not sure if you can all see that. Page 7, number 6. I'm going to use another color. Okay, we're going to actually find the value of this problem. We're going to have 4 and 3/5 plus 6 to the 3rd times 6 and 1/5 minus 2. Now, this is a PEMDAS problem. Now, there is a tutorial on this in the Google Classroom and also on YouTube. You can check out my channel or Mr. Rez's channel. One of us has the video on this. Okay, so let's look. Anytime we have fractions, we want to convert them into decimals. So I'm going to write over here that 3/5 is the same as 0.6 or 0.60. And 1/5 is the same as 0.2. So if you use your calculator, you divide 3 by 5, you get 0.6. If you divide 1.5, you get 0.2. So now that I converted the fractions into decimals, I'm going to take the decimals and place it into the fractions. So now the 4 stays. I'm going to take the 3/5 and I'm going to put in 0.6. Plus, I'm going to bring down the 6 to the 3rd power. Times, I'm going to take the 1/5 and put the decimal, which is 6.2 minus 2. Now, my next line, I'm going to do this one in black for you. Okay? So I took care of I did my decimals. The first thing in PEMDAS is parentheses. So I'm going to use the black to show you that P parentheses. I'm going to subtract 6.2 from 2, and I'm going to get 4.2. I'm just going to bring everything else down. Okay, that takes care of my P for my parentheses. Now, we're going to now do anything that has an exponent because the next part is E, which is exponents. So here's what's an exponent. I'm going to bring this down. I'm going to expand out 6 to the 3rd, which is 6 times 6 times 6, and I'm just going to attach what's left here. I need to figure out what 6 times 6 times 6 is. So I'm going to bring this down. 6 times 6 is 36. 36 times 6 is 216. Let's just double check that. 36 times 6, this is 6, 3, 216. Times 4.2. So I did my E for my exponents. This should be a plus sign. Sorry, guys. That's actually a plus. It's 4.6. This is a plus. Okay? Now, let's go now and do multiplication because that's what comes next. We read the problem from left to right. We got to multiply because that's what comes first. So we're going to multiply 216 times 4.2. So let's do that right here. 216, and I don't care about the decimal right now. Let's do this. This is 12. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. Cross this off, put a 0. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6, and this gives me 8. Add them up. 2, 7, 0. I get 9, 0, 7, 2. Now this one had 1 dp decimal place. So here's the decimal here. I'm going to move it over. Now I get 907.2. 907.2. I took care of multiplication. There is no division, so next I have to add. I'm going to add 4.6. Now, I'm going to take this 4.6 and line it up under the decimal where it belongs. So 0. Sorry. So I'm going to line up the 4.6 and add 2 plus 6 is 8. 7 plus 4 is 11. 1 plus 0 is 1. And 9 plus 0 is 9. So now this is 8, this is 1, this is 1, this is 9. The answer is 911.8. That is the value of this page. All right. On page 8, you're going to create your own problem based on the packet. We're going to actually go over page 9 now. Okay, page 9 looks like this. Here we go. Page 9, an equation question. All right, I'm going to write that down right here. Page 9. Number 8. Here's what we got. I'm going to say D for draws. I'm going to say V for volume. I'm just going to write 2. We got 5. 3. We got 7.5. And 4. We got 10. So first off, we need to figure out how do we go from 2 to 5. Simple. This is what we're going to do. Let me move this down so you can actually see. Okay, so here's what we're going to do. 2 things. I can find the unit rate of dividing the volume by the draws, and I'm going to get 2.5. So let me say that again. I can find the unit rate by dividing 5 divided by 2, and I'm going to get 2.5. If I divide 7.5 by 3 draws, I'm going to get 2.5. If I divide 10 by 4, I'm going to get 2.5. So from 2 to 5, I got to multiply by 2.5 because that is my unit rate. Okay, I'm going to write times 2.5 with the black marker times 2.5. So I know that I got to multiply by 2.5. So now I got to write an equation. So V represents the volume. So in order to get the volume, I have to multiply 2 times 2.5, which is my D. So I'm going to write 2D is equal to my V. Now, in place of D, I'm going to write 2.5. So I'm going to take 2.5D is equal to V. That is my equation. So 2.5 times 2 gives me 5. 2.5 times 3 gives me V. 2.5 times 4 gives me 10. Now, let's go on the other side. It says that if the total volume, we need to figure out the total volume if there are 17.5 cubic inches. Okay, so the volume is 17.5 cubic inches. So now, if the equation is 2.5D equal V, and the V equals 17.5, I'm going to take the 17.5 and substitute it. So now I got 2.5D equals 17.5. Make the wall method to solve. Multiplication is what's shown by the 2.5D. The inverse is division. I'm going to divide by 2.5 on both sides in order to figure out what D is, and D is going to be equal to, let's do it, 2.5 here, 17.5, move it one place, bring it up, and we know that this goes 0, this goes 0, and let's figure out what this is going to have to be. So we're going to have to do some math over here. 25 times, let's try 7, this is 35, this is 14 plus 3 is 17, so I know that I have to have 7. So D equals that you're going to have 7 draws. So you're going to need 7 draws to satisfy this equation. All right, we're in number 11 I've modeled for you. I'm actually going to model page 11. I'm going to model page 11 for you. And then I feel that the rest of them, I'm going to model page 11 for you, page 15 for you, and then the rest of them I feel like you'll be able to mostly do on your own. So we're going to start on page 11, so let's get that problem done. Let's take this paper down. Let's bring up the next paper. All right, here we go. Here we go. Be patient. Thank you for being patient. In the meantime, you could read and annotate the problem that we're going to do. Okay, so that problem that we're going to work on is on page 11. Everyone find this page. And we're going to figure out which expression matches this table. It has to be true for all the values. So this is page 11. Number 10, and here's what we got. X, Y, I'm just going to write down what we have. 1, 5, 2, 7, 3, 9, and 4, 11. Okay, this is the table that we have. Okay, we need to figure out which expression is going to make this table true. Alright, so let's look at what we got. I'm going to start with choice D to show you. Alright, let's look at D. D says 2x plus 3. So here's what I'm going to do. I'm going to test every value of x and substitute it. So when I take the number of x and substitute it in, I should get my y. So let me show you if x is 1. If x is 1, 2 times 1 plus 3. 2 times 1 is 2 plus 3, which is 5, which is what the y is. So they match up. Let's do it when x is 2. In place of x, I'm going to substitute it 2. So 2 times 2 plus 3. This is 4 plus 3, which is 7. Check. Matches 7 on the chart. If x is 3 now, x is 3. Using this equation, we're going to do 2 times 3 plus 3. This is 6 plus 3, which is 9. This is true. If x is 4 now, we're going to take 4 in place of x. 2 times 4, because that's x, plus 3. This is 8 plus 3, which is 11. So now I can say that D is the answer because every single value of x, when I plug it in, substitute, replace it into this expression, and I add 3, I get 5, 7, 9, and 11. That is the correct answer. Moving on, page 12, I modeled something very similar. So you're going to refer back to that example, so I'm not going to do that page with you. And the same thing on page 13, we modeled how to do that one. But we're going to pay our eyes and ears. This question I just modeled before, so you can look back at that example. But I am going to model page 15 as I promised, because some people asked for help on that one. So page 15 is a PEMDAS problem. I'm going to model how you do this one. All right, so this is now page 15, order of operations. So now this is page 15. We got number 1. Okay, here's what we got. Which expression or expressions have the same value of 12 squared? So first of all, 12 squared, when I expand it out, the exponent tells me how many times to multiply the base. I got 12 times 12, which is 144. I got to figure out if value A, expression B, and expression C equal 144. And it could be 1, it could be 2, or it could be all of them equal 144. So let's look at A, for example. Problem A. Okay? We have 20 squared minus 18 squared. We know that if 12 squared is 12 times 12, 20 squared is 20 times 20, which is 400. We're now going to subtract. Again, if 12 squared is 12 times 12, 18 squared is 18 times 18. We're going to subtract, which is 324. When I subtract 400 from 324, I get 76. So A is a no-go. It's not equal to 144, which is 12 squared. Let's look at choice B and see if that equals 144. Okay, so here's choice B now. Choice B. We have 8. This one's a little tricky. 4 squared plus 2 to the 4th. So let's look at what we got. We're going to do, according to PEMDAS, the parentheses first. And in the parentheses, I got a 4 squared. So 4 squared is 4 times 4. So I'm going to write 8 times 4 times 4. That means times plus 2 to the 4th. I'm going to simplify. This gives me 8 times 16 plus, now I'm going to do this. This is 2 times 2 times 2 times 2. This is 4, 8, 16. So now I'm going to multiply 16 times 8 first because of PEMDAS. I'm going to multiply, then add. So 16 times 8, this is 48, this is 128, and now I'm going to add 128 plus 16. I'm going to do it right here. And guess what? We get 144. So expression B is a yes. Let's go look at expression C. So we got 15 squared minus 3 to the 4th, so it's the same thing. We know 15 squared is the same as 15 times 15, which is 225. I'm now going to subtract it from 3 to the 4th. 3 times 3 times 3 times 3. 3 times 3 is 9, and another group of 9 give me 81. So 225 minus 81 is 144. So the answer is going to be expression B and expression C, both equal 144. And there you have it on how you are going to get your answer. So again, it's B and C. Okay, number 16 we modeled for you. 17 is pretty straightforward. We've done page 18 on inequalities last week. You can actually cross off page 19. You do not have to do page 19. Let's go to page 20. We modeled last week for you, so refer back to that model. 21 is a strictly pattern question. You're capable of finding that one out. If you need help, reach out. This one is a recap of above and below. So anytime you see a positive integer, it's above. Anytime you see a negative integer, it's below. This question was modeled for you in a tutorial video. So that was done for you. Refer back to that. And then this question about notebooks is very similar to what we did. I do want to go quickly over something. When you have a coefficient, okay, so for example, if you like when you see in your exit ticket, if you have R, there's no coefficient, which is the number in front. You place a 1. So 1R is the same as R. M is the same as 1M. No coefficient, you put a 1. And if you have any questions, guys, feel free to reach out to Mr. Rezanai, and we'll be more than happy to help you. Bye-bye.